Hello everyone, welcome back to my YouTube channel. In this video, we shall discuss a question associated with acid dissociation constant. So let's get started. Determine the acid dissociation constant value of a 0.02 molar aqueous solution of propanoic acid with a pH at equilibrium is equal to 4.88. From this question, there are two clues that is given to you. One is it is an aqueous solution and is propanoic acid, which is the weak acid. So in terms of weak acid and it is in aqueous solution, it means that your pH shall not be equivalent to negative log H+, but instead it should be equivalent to negative log H3O+, the hydroxonium, because of the aqueous solution. Therefore, in this question, it states that the pH is equivalent to 4.88, so it's equal to negative log H3O+. Hence, we can find what is the concentration of H3O+, should be equivalent to 1.3183 times 10 to the power of negative 5. So this is the concentration of H3O+. Right. So I'm just going to explain to you why it is H3O+ instead of H+. Right. This is a propanoic acid, right? Propanoic acid. So you should have 3 carbon, and then because this is propanoic, right? So you should have OH and double bond O. So in the question, it states here that it is in aqueous solution, means that you need to add water. So since you already add water, you are going to remove the H around here, so you will get still 3 chain carbon, so at the end here you will end up having like this, plus, because you already taken away 1 hydrogen, so you will get H3O+. Right? So this is why you have H3O+ over here. So this equation is really important so that you can make your ice diagram. So initially, it states that this is 0.02 molar aqueous solution. So here should be 0.02. So there's no dissociation occurs in the beginning. So because this is just 1 mole, so negative X, positive X, positive X. So here will be 0.02 minus X, X, and X, right? So from the calculation that we have done just now, the concentration of H3O+ is equivalent to 1.3183 times 10 to the power of negative 5. Right, so this means that the value of X is equivalent to this value. So what we need to do is we need to substitute all of these X's with this value. Alright, so in saying that, we can calculate the Ka, which is equivalent to whatever in the product. So product, we only have X and X, divided by whatever in the reactant. So it should be 0.02 minus X. So given in the calculation before this, your X should be equivalent to 1.3183 times 10 to the power of negative 5. So we are going to substitute that. So you should get 1.3183 times 10 to the power of negative 5 to the power of 2 divided by 0.02 minus 1.3183 times 10 to the power of negative 5. So you will get your Ka should be equivalent to 8.6947 times 10 to the power of negative 9. So in the question, you were asked to calculate the acid dissociation constant, which is the Ka. So this is the final answer for this question. Thank you very much for watching this video from the beginning till the end. So I'll see you again in the next video. Goodbye.